pharmacokinetics. So I chose to look more into these drug transport proteins that I was talking about on the last slide. I specifically picked to focus on transport protein OCTN1. There's currently no relevant data on how this alters how children process medications. So OCTN1, it's an organic cation and ergothioneine transporter, and it also plays a role in L-carnitine tissue distribution. So this has some pretty serious clinical relevance because carnitine is necessary for the beta oxidation of fatty acids. And if you were to do something that would alter the beta oxidation of fatty acids, that would slow down the process of getting the molecules into the TCA cycle, the electron transport chain, and slow ATP production. So if another drug were also a substrate for this transport protein with the carnitine, and it would block it, and it would be sort of competing to get through, and the carnitine wouldn't be able to get through as often, this would have a lot of negative metabolic outcomes. So if I were to do this research proposal, I would determine gene expression of the OCTN1 in various ages, and then do some sort of statistical analysis to see if I could apply this data to like a current model of the human physiology in order to predict how it would influence drug disposition. So I would take tissue samples, probably of the intestine. OCTN1 is expressed in both the kidney and the intestine, but because of the oral mode of administration of acetaminophen, it would probably have more influence in drug absorption in the intestine. So I would take tissue samples from mice at various ages all the way up until adulthood, and adulthood for a mouse is considered to be about 8 weeks. I would use some sort of kit to extract the total membrane proteins from these tissues, and then I would run it through a liquid chromatography system that was tandem to a mass spectrometer. So the first portion of it, liquid chromatography, would basically run these samples through a teeny little column and separate the proteins in the sample based on size. And then a mass spectrometer basically blasts the samples with electrons to break them down into smaller ions. And then this data is spit out, here, it would look something like this. So the data is spit out and it breaks it up based on like mass to charge ratio. So each of these peaks would show you a different protein. And then the size of the peak, or the peak's intensity, would tell you how much of that protein is in the specific sample. So you would look at how much of OCTN1 was expressed in each age sample and do some sort of statistical analysis to determine if there was any age-based expression. And if there was, the hope would be to create some sort of formula that could be able to alter adult clinical data to include how it would change if it were functioning in a child. And then this would be included in some sort of pharmacokinetic model to predict outcomes. So that way you could use adult data to turn it into something that would be relevant for kids. So the whole point of my presentation was hopefully to outline this process, and I really wanted to bring to light the importance of improved research. We also need to raise awareness for governmental agencies, pharmaceutical agencies, and academia to sort of come together to combat this issue, because there's a lot of research that needs to be done before we have enough information to properly dose children. So if you have any questions. Yeah.
What motivated you to choose this topic?
So I'm going to pharmacy school next year, and I currently work at CVS Pharmacy. And for things like antibiotics, liquid Tylenol, all that sort of stuff, physicians usually type in the weight of the child, and it just spits out a dose, and they just throw that on the prescription and send it to us. And my pharmacist talks about it all the time. Every time we fill something, he has some sort of something to comment on, because a lot of these doses are unbelievably large. Like, you can tell they just plugged in the number, move forward, and whatever, and it's not really a safe dose for these kids to be taking. So that sort of raised my awareness for it, and that's why. So I picked it. Yeah.
I know this is a little different, but how does this impact giving vaccinations at and near after birth? Because there are, obviously that's part of an immune response as well, but
yeah.
I don't know if
that's
you know
a good
anything
question.
about that.
No, I mean, again, I would just think you would have to probably alter the concentration of the dose that's going into the body to be in accordance with however far along that child is at the time. Yeah.
Have you read anything that correlated adult dosing usage in children slowing development of organs?
What do you mean?
like adult doses being used in adolescents or infants, does that slow the development of their organs?
Oh.
Like their kidney function?
That's a good question. I'm not entirely sure. Most of what I read just, it more so increased the side effects that kid would face because they reach a toxic level much faster than an adult would. So I would assume yes, because if you start heading into acute kidney and liver failure as a child, that's probably going to have some pretty serious consequences. So, super.